All right, everybody. So here we are onto Unity. We're going to be using Amplify. I'm using HDRP, but of course, the version of Unity does not matter. So here I have some other applied usages of the shader, just so we can see here. So this is a very subtle holographic effect here at the bottom. And you can kind of see how I also changed the color of the holographic effect. It's not this rainbowy color. It's a more bluish green type of tint. So you can actually modify the color of the shader itself. Let me show you here. So we can actually select different curves, and you can see here how it changes, how the light kind of works. So it's a very customizable shader. So let's create the actual shader here. So we're going to be making a amplify shader. We're going to make it a surface shader. We can actually already select here a unlit HDRP shader. We're going to call this card tutorial. So we have the card tutorial shader file here. What I'm going to do actually is that I'm also going to create a new amplify shader function. We're going to call this holographic tutorial because we're going to be using functions here. So this way we can reuse this effect anywhere. So let's first, here on our actual card, what we're going to do is that we're just going to do a texture sample, and we're going to call this one illustration, and we're just going to plug this into the color, and for the alpha we can leave it alone. And if we save it here and we create a new material, so you can right click the shader and go into create material. Let's do tutorial. I'm going to duplicate this little fella here, and now I'm going to apply this material. So we have just a white plane. So I'm going to drag and drop the Charizard illustration here. So now we just have a flat out card illustration, unlit, nothing fancy. So what we're going to do now is that we're going to go inside of the holographic function here, the holographic tutorial, and we're going to actually start building the holographic effect. So the plan behind this is that all we're doing is that we're taking a normal map, and we have a gradient texture that represents light, the different spectrum of light colors, and we're going to be bending that texture based on the normal map, but also based on the view direction and the direction of the camera, right? So it looks like it's actually reflecting. This is the bread and butter of the effect. So for that, we're going to need, of course, a texture. So let's just press T and make a texture sample. And we're going to call this warp texture. Okay, this is going to be our normal map. Now, something important is that since this is a normal map, we actually want to use the normal map information. So if I go here for warp, here we go. So here I have some normal maps. So if I take, for example, this normal map here, you can kind of see what it looks like. And one important thing is that you got to make sure that this little checkbox here, unpack normal map, is checked. If this is not checked, look at what it looks like. You can see how weird that looks. So with this checkbox checked, it also creates a new input called scale. So this scale input is what we're going to use to control how intense the normal map bending is. So I can show you here that I actually have a holofoil distortion strength variable, and you can see what it does, that as I change this value, the holographic effect becomes more and more pronounced. Of course, it looks bad if you push it too hard, but yeah, so let's create a new variable here. So just a float variable. It's going to be a property, and we're going to call this holographic distortion strength. So we can make it a minimum of 0 and a max of 1, and the default value can be 1. And if I drag and drop this here, you can kind of see that as I move the slider, look at what's happening with the normal map. The normal map kind of disappears, right? So this is part of the trick here. So this is going to control the strength of our normal map. So if I go over here, right, we have this holographic effect. This is very reminiscent of Yu-Gi-Oh! So if I make the holographic strength 0, you're going to notice that this is now a cold foil or a mirror foil, right? So think of like, you know, mirror foils from Magic the Gathering or Flesh and Blood and card games like those. So the normal map is kind of the pattern, controls the strength of the pattern of the foil effect. So now, what else we want to do is that currently this normal map is just going to be one single image, but we actually want to be able to control the permutations of this pattern here. We want to be able to repeat it. So let's grab a texture coordinate. So you can do texture coordinate. What we're going to do here is that we're going to make a scale and offset. And what we're going to do is that we're going to make a new property called warp map tile, and we can default it to be 1. So let's put that into the scale. And finally, we can also make an offset. And this offset can be a vector too. So we're going to do warp tile offset. And the default value can be just 0, 0. Now, if we drag this over here and we put this into the UV, you're going to see that nothing changes. But if I make this 2, you can now see that the pattern repeats. And I can, of course, make it repeat as much as we want. So this is very useful. And the same goes for the offset. I can, for example, put this at 0.5, and you can see here that we are essentially moving our normal map, so the foil pattern. All right, great. So now we have this normal map in place, and we want to make this affect a color gradient texture. So here we can do a color gradient. So it's going to be a new texture sample. We can call this color gradient, and I have here some ramp textures, and you can see here there are different permutations of rainbows. So let's just pick a random rainbow here. Let's take this little rainbow texture. They're slightly different. And you're going to notice that if I put this into the UV, we're kind of warping the rainbow to be in the shape of this texture. So this is the basic concept, right, behind what we're trying to do. But the difference is that we want to actually distort this based on our view direction and our camera position. So I can actually show you here. So this is going to be our warp texture logic. Now I'm going to move a little bit down, and what I'm going to do is that I'm essentially going to make a new float. We're going to call this float, it's going to be a property once again. We're going to call this distortion distance. Default value of 1. So this distortion distance is essentially kind of implying the distance that the light source is from. So we're going to negate this, and the reason why we want to negate this is because we don't want any negative values. So if we bleed over to the negatives, they're just going to be looped right back onto regular values. And we're going to take a view direction, and we're going to make this view direction tangent. So a tangent view direction, and we're going to normalize it as well. What we're going to do is that we're going to multiply these two elements here, right? So these are actual vectors, so they're directions, points in space. And we're going to add our view direction to the warp texture. So now that we have this addition going on here, if we put this here, it's already going to do some things that is going to make this texture be based on the vectors, right? And we can actually just test it out before we do anything else. Let's just test it out. So what I'm going to do is that I'm going to plug this into the output. So the name of this function is holographic tutorial. So now we want to put our holographic tutorial here on the illustration. So what I'm going to do is that I'm going to search for holographic tutorial, and we're not going to do this later, but just for showcase purposes, I'm just going to straight up add those two things onto each other. So all of those variables that were here are now also going to be added here. So when I save this, let me save the function as well. So when I save this and I go back here, you're going to notice that now our tutorial card has a warp texture, holographic strength, warp tile. It has all of those little settings there. So what we're going to do here for the warp texture, I actually have some of these saved up. So let me get here the warp textures that I had set up. So I can go into textures, light warps. So we can put, for example, let's put the galaxy foil on the warp texture, and on the color gradient, let me just do a very generic rainbowy texture. So you can kind of see here what's going on. We are already getting a version of the holographic effect, but there's a few problems. First, it just looks bad. Like the colors blend very nicely here. Meanwhile, here, they're just being added on top. It looks a little bit cheap and fake. But we can see here the holographic strength is working. So you can see that this is a cold foil. This is, a regular foil. The tiling is also working. I can tile the warp texture as high or as low as I want to. The offset is also working, so we can move the holographic effect. So all of those things are working pretty nicely. Even the distance here, you can see that as I increase the distance, we're increasing the bendings of light as one would expect it to happen in real life. So the current elements are working, but the blending is not really nice. So what I did is that I made a mask. That's the first order of business. So we want only the background to be holographic. We don't want the main character to get the holographic effect. So everything that you want to be holographic is going to be painted white. Everything you want to be kept is going to be black. So I called this file Charizard mask. So what we're gonna do here is that I'm just gonna make a new texture sample, and this is gonna be our mask. So we're just gonna call this mask. It's gonna be a property, already is a property. And here's what we're gonna do here for us to do the blending. So here we have the illustration, right? So what we're gonna do with this illustration is that we are going to blend it with this function using some complicated tricks. So the first thing we're gonna do is that we're essentially gonna take this mask right here, and we're going to multiply it. Just multiply, flat out multiply, and we're gonna make a new float value, and this is gonna be our global holofoil alpha, default value of 1. And what this is doing essentially is that we're going to use this value to turn off the effect or control the overall intensity of the effect. But then we're going to blend this using a blend operation. The one I find looks the best is soft light. So here we have soft light. So the source is going to be the holographic foil. The destiny is going to be our illustration, and the alpha is going to be the mask. You're going to notice that this is already going to look a lot better, but not quite perfect. So here we have it. Now let me put the mask here. So now we have the color foil being blended a little bit better, but it still doesn't look vibrant. The colors, they become kind of washed out, right, by this. And of course, we have the holofoil alpha, so I can, turn the effect off, essentially, if I put it at 0, or I can turn it back on if I put it at 1, but it's still not there. It blends nicely like a surface of light would, but it lost all of the vibrant colors. So how do we fix that? Well, we need to essentially mix back in and embed into the illustration itself some of the color values. So the way we're going to do this is that we're going to have a new float. We're going to call this, it's going to be a property. We're going to call this foil vibrance. And we're going to set it to be 0 by default. And we're going to create a new multiply, and we're going to multiply the mask by the color vibrance. Now, this is going to be fed into a lerp. What a lerp does is that it takes whatever is plugged into A and replaces it by whatever it's plugged into B. So we're going to take our illustration and we're going to replace it by the holographic effect based on the alpha that is our foil vibrance, but only affecting the mask. And now, if we put this into the destiny, there's going to be a problem, but you're going to see that now we're going to have the colors being a lot stronger. The colors are going to pop a lot more. So if I go here to my card and I go to my foil vibrance and I increase it, you can kind of see that if I put it at 1, let me increase the foil distance a little bit, that we have restored the vibrance of the colors. But now, we can't see the background, right? Like, okay, sure, it works, but we can't see the background. So let's put the color vibrance at like 0.2. So now we can once again see the background, but it's still not quite there. Well, what we need to do is that we need to decrease the foil alpha by the amount that we increase the foil vibrance. And then you can see here that it blends like a real life card would. So in order for us to do this mathematically, instead of doing that every time on the material, is that we can take our foil vibrance and we can invert it by using a 1 minus operation. And this inverted value we can now multiply here on a new multiply. And this is the new alpha for our blend operation. Essentially, you can see here that the 1 minus is set to be completely white, which means that it's set to be 1. This is set to be 0. So when this is 0, this is 1. When this is 1, this is 0. You can see it flip there. So the important thing here is that when foil vibrance is at 20% intensity, this means that the mask for the soft light will be at 80% intensity, unless overwritten by these two operations, right? So we're not going to be blending twice on the intensity of the colors, and the colors are going to look a lot more realistic. So this is how we're actually blending our holographic effect. And you can see here that it looks pretty decent. I can change the mask here, for example, and look at that. All of a sudden, we got ourselves a pretty nice looking holographic effect. But this is still not perfect though. You can see here how when I move my card horizontally, it moves a lot. But when I move vertically, it doesn't really move all that much. Well, This is because we're not taking really diffraction into account. So diffraction is a physics phenomena that's way too complicated for this video, but it's somewhat easy for us to take into account because it's essentially reflection that moves things a little bit to the left or to the right on the color spectrum. That's the bottom line. Since we're not calculating things, per particle or anything, with our level of precision on a shader is a lot more simplified, right? We only care about the pixels on the normal map, pretty much. What we can do here is that we can make those changes. Let's begin here to add a new section to take diffraction into account. So what we're going to do here is that taking off from this normal map, we're going to blend it with a vector. So the forward light vector on Unity is the Z. So we're going to make a vector 3, which is going to be a vector, right? So this vector is going to have 0, 0, 1. So it's essentially multiplying things by 0 on the X and the Y and keeping the forward direction. And we're going to lerp it. So we're going to put this on the A and our normal map on the B. And we're going to lerp it. And this lerp is going to be based on the holographic distance. So the holographic distance is now also going to affect how much we warp our vectors alongside the X, the Y, the Z. So now what we're going to do here is that we're going to take this addition, we're going to keep it over here, this is fine, and we're going to split this lerp. We're only going to use the X and the Y as is. After all, UVs are vector 2's, so we only care about those. And we can append by pressing V and clicking. So we're going to put vector 2 here. Now we only have the X and the Y. And we're going to add these vectors here together. And the first thing that we want to add to this mix here of directions, because these are essentially directions. And the very first thing we want to do is that we want to add the camera position. So the camera position is going to change the UVs that we use to warp the color ramp. So what we're going to do here is that we're going to search for rolled space. Oops. Oh God, my computer froze a little bit. Rolled space camera position. And if I we're going to take just the X here. And if I put this here, as I move my camera, this addition is going to be changed. Finally, we also want to take into account the reflection vector of the card. Holographic cards in real life, they usually display more holographicness when they are reflecting against your eye, right? This is why as you move them in your hand, the holographic pattern kind of shifts around. So there's a way for us to do this, which is actually rather simple. So let's make our reflection logic here in the bottom. So we're gonna, once again, I'm gonna just duplicate this rolled space camera position here because we're gonna reuse it. And we're going to subtract it. So the whole vector, the whole thing. And we're going to take the vertex position, which is pretty much the position of the faces of the 3D model itself. Even though it's a 2D plane, it still has vertex positional data. And we're going to transform this position. So this node here. Essentially, we need to take this from object space to rolled space. Why? Well, because this is the rolled space camera position. So we need to do the operations with both things on the same position coordinates. So we're going to put this here, and we're going to subtract those two vectors. We're going to normalize it, which means essentially to clamp it between 0 and 1. And now what we're going to do is that we're going to use a node called reflect. So reflect is pretty much, you can do this with dot products, but since we already have reflect here, we're just going to do that. So this is going to be our angle of incidence. And for the normal map, we're going to use the rolled normal, which is just the surface data. So the normal is a vector that points from the face of the 3D model outwards in a direction. So we're taking the direction of the normal from the 3D model and using it to reflect based on the difference between the camera position and the object position itself. And finally, we're going to turn this back into object position, so we can do a transform rolled to object. After all of these are in rolled space, right? So we want to put them back into object space. So this is going to be our reflection logic. And we're going to take the result of this and add it here. So now we have this funky looking thing that takes reflection into account. So we have added all of those things together. Now, what I'm going to do here, unplug this. We are going to take this addition here, and we're going to add it to a texture coordinate. So just a UV set. So this is going to be modifying a UV set, which looks perfect. Now, I like being able to rotate this texture. So I'm going to make a rotator. We're going to plug this result into the UV of the rotator. And what I'm going to do here is that I'm going to make a new variable. I'm going to call this variable color ramp rotation. It can be a default of 0, but it does need to be a property. We're going to plug that into time, and the anchor, we're going to put 0.5 and 0.5, so it rotates from the middle. We're going to drag out a scale and offset. We're going to keep the scale as it is, but we're going to offset this UV by the result of our vector addition and multiplication shenanigans. And now this, we're going to plug into the UV. Very trippy. So now if I save this, let me just make sure to move my variables around so they look good. So now we kind of have here our effect, and you can see, okay, perhaps this is not the best example because this normal map doesn't really have like data on both ends, but let me change the normal map here. Okay, let me see if I need to rotate. Maybe I need to rotate a little bit. Okay, hell yeah. All right. Okay, I needed to rotate the color ramp rotation slightly. But now you can see that I have a holographic effect that is affected by the camera position and both ASICs. And also you can see here that as I move my camera closer or further away, it also affects the bending of the holographic effect as one would expect. So this is pretty much the whole thing. This is pretty much the whole effect for the holographic shader. You can play with these variables to achieve very weird looking results like these ones. You can do a bunch of cool stuff with these. I personally recommend using normal maps, but you can see here that, also the holographic strength, where is it? Alpha, vibrance, holographic distortion strength. Sometimes I like keeping it kind of low. It works a little bit better sometimes. But you can see here that these effects, like you can put virtually any normal map here and it's going to yield a cool looking result. And even those funkier ones like these, for example, these are great, in my opinion, examples of holographic distortion. Do keep in mind that the normal map, if you make it too strong, it can sometimes look a little bit pixelated, but you can just adjust it like this and you can see that it looks absolutely amazing. You can change the tiling of the normal map. Ooh, this looks very trippy, for example. But yeah, folks, hopefully you enjoyed the tutorial. And this is a shader function, so you could technically, use this function in any of your shaders and add a holographic zing to any of your materials. So yeah, thank you so much for watching, and please consider subscribing.